You might see this as just the letter A, the same one you're familiar with. But what if I tell you some people perceive this character differently? Some people might see this color red, or another person might experience a specific smell every time they see that character. This is because of a neurological phenomenon called synesthesia. Synesthesia can be defined as a condition when a sense triggers another sense at the same time.
For our project, we focus on grapheme color synesthesia, which is a specific kind of synesthesia where you look at characters and simultaneously associate colors with them. For our database, what essentially we had 4 different languages, and we had different characters for those languages. For each different character, there was a record of what color synesthesia patients essentially saw. So over here, for instance, for the letter A, people saw the red color, or for the letter B, people saw the blue color. And that is how our database was organized by Japanese scientists.
This is a graph that we created in Python that was meant to show the ranges of colors that people saw who had synesthesia in the 4 different languages. You can see in the hiragana graph at the top left, there's like warmer colors overall. In the graph below it, there's cooler colors overall. And in our Latin alphabet, the one that we're familiar with, there were darker colors overall.
Now this graph is essentially, what it is showing you is that the amount of colors people saw in the kanji character. So what this is essentially showing you is that some people saw 2 colors, or some people even saw 6 colors, or some people saw 2 colors. The idea is that the amount of colors seen essentially depends on the patient. Now, this graph, what this essentially is showing you is that what we want to test was the relationship between the complexity of the character and the amount of colors people saw. How we define complexity over here is by the number of strokes it takes you to draw a certain character. So the higher the number of strokes it takes you to draw a certain character, the more complex it is for you to draw a certain character. Over here it is showing you that for the Japanese character, which is harder to draw since it's more complex, you're seeing more colors, whereas for the Latin alphabet, you're just seeing 1 color since it's not as complex to draw. And that is how we essentially saw a positive correlation between complexity and the amount of colors that you essentially saw for different characters. Now this is Melissa McCracken. She's an artist who suffers from synesthesia, but she uses it to her advantage. She listens to music and then she paints whatever she hears. For her, synesthesia brings a completely different visual dimension, and that is what we're trying to test here. The idea is that perception at the end of the day and how we perceive the world is completely different, and that is how Melissa McCracken sees music and she paints whatever she essentially hears.
We all perceive the world differently, and the presence of synesthesia just shows that there's no incorrect way to experience the world, only many different ways that all contribute their own forms of beauty. Thank you.
Thank you.